All right, here we go with 10.3. We're going to do 10.5 together in the Zoom, and I'll go over 10.6 in this video. All right, so 10.3, we're going to look at areas of regular polygons. All right, you should know what regular means. And if you take a look here, all right, this idea of the triangle is going to be very helpful, right? Area is the amount of space taken up inside a shape. And so here, I tried to draw a triangle here. In this pentagon, there are 5 triangles, okay? And so if you think about, well, if I find the area of one triangle and there are 5 triangles from the center, then one triangle times 5 of those is going to be the whole area of this pentagon. So that's our goal here, right? And so we're going to use the area of the triangle, 1/2 base times height. We're going to use A and S. You'll see why in a little bit. Okay. S is the side length, and A is the length here. It's the height. Okay, it's an altitude kind of. It creates 90 degrees. All right. And so if the area of a triangle is 1/2 base times height, or 1/2 A times S times, in this case, 5 of those, then that's how we figure this out, right? If it was a hexagon, then it would be times 6, because there would be 6 triangles, and so on, right? And so that is what our formula is, okay? A times P. The A, here's some new vocab here. The A is called the apothem, okay? And so it's from the center of the regular polygon to the midpoint of a side of the polygon, right? It is a perpendicular bisector. So it cuts the side in half and it creates 90 degrees, all right? It also, if you can see where I'm highlighting, it cuts this angle in half as well. That's going to be important, all right? You'll see in a future example here, right? And here I underlined capital P is the perimeter. Okay, the perimeter is actually N times S, right? N is the number of sides. S is the length of that side, and so the perimeter would then be, the number of sides times the measure of that side, right? That's the perimeter. Okay. I would actually probably use 1/2 ANS, all right, going forward. So then the radius, okay, if you look in this picture where I'm highlighting, the radius is the segment joining the center to a corner, all right, what we call one of the vertices, all right. So the apothem goes to the midpoint of a side, the radius goes to an angle, all right. And so I'm going to go over some examples here. This one's pretty straightforward, all right. This should say a regular octagon. Octagon is 8 sides. We gave you the apothem of 60.4, and each side measures 50. That's your S value. All right, so this one's pretty straightforward. 1/2 times A and S. All right. In example 2, okay, again an octagon. All right. This time we give you the radius as 23.5. Each side is 18. All right. And so when you create the apothem, remember it cuts this 18 in half. That's why this is 9. All right. And then you got to figure out, well, what is the apothem? Because you need the apothem for the formula. It's 1/2 A and S, right? N is going to be 8. S is 18. And so we use Pythagorean theorem here. Okay. This green lettering here, this is for the calculator. I'm not going to explain this right now, but because when you do the Pythagorean theorem here, you get a never-ending decimal value. So instead of rounding here, okay, this is one of those where, in the previous step, you do the square root of 471.25 and you get this answer, right? So instead of rounding here to 21.7, you're going to use this and then multiply right away by 1/2 times 8 times 18. So this is one of those where when you multiply right away in your calculator, it's going to show up as ants, okay, the previous answer. In example 3, all right, I think in the blank notes, you're only given this 14, okay, you're only given this 14. So then, you know, how do we figure out the rest of the problem? All right, so we create a triangle, right? This is a hexagon, so there are 6 of these isosceles triangles inside this hexagon, right? Well, think about, let me do something here real quick. Okay, so I put in these black radii here, okay? So there are 6 of these triangles, right? And if I were to go around in a circle, right, with these interior angles, right, a circle is 360 degrees. So then if there are 6 of these angle measures, right, there are 6 of these angle measures, right, well then they got to be congruent. So 360 divided by 6, which is the work right here, is 60 degrees. So each of those angles in the center is 60 degrees. And don't forget the apothem cuts that angle in half. That's why this is 30. All right. So this triangle that I'm highlighting here is actually this triangle right here. Okay. So that's 30. We don't know the A value, the apothem. We know this is 7 because each side is 14 and the apothem cuts it in half. All right. Now you got to use your special right triangle knowledge. If this is 30, then this must be 7. Then this must be 7 root 3. Alright, so these special right triangles keep coming up. This time you're given the radius. Okay, again, you know, I try to create a triangle here with this red line. This is a hexagon, so this is going to be 60 degrees again and divided by 2, which is 30. And if you're given the hypotenuse, remember the radius here acts as your hypotenuse because it's across from the 90, and so therefore half of that is going to be the shortest side, which is 4 root 3, and then that means each side here is 8 root 3. All right. Okay, and then you can also figure out what the A value is by special right triangles. Here, this is a regular triangle. It's an equilateral triangle, so therefore you know that each angle is 60 degrees, which means it cuts this to 30. And the apothem, we drew it this way. Okay, you could, yeah, we drew it this way. And so again, special right triangles keeps coming up. All right. This is 5. Okay, that's the hypotenuse. All right, that's the radius. Okay, because remember it goes from the center to the corner, and so therefore this must be the shortest side. Okay, that's half of the hypotenuse here. And then this time you're given the apothem, right? Again, 30 degrees. All right. Okay, so if you're given this, all right, then you know this is 30, and you can figure out the medium side, and then the whole side here. All right. So yeah, that's 10.3, I believe. All right, and then if you have questions, please go back and watch the video again, or if you have questions, please ask me during the Zoom session or shoot me an email. Okay. So for circles, all right, you got to know the definition of a circle. Please look this over. All right. And then there's a lot of stuff we're going to look at here. Okay. You should know what a semicircle is. Adjacent arcs. Right. Arcs are parts of a circle around it. Concentric circles are a circle within a circle. A central angle is the angle at the center. That's why it's called the central angle. Right. A major arc is more than 180 degrees, more than half a circle. A minor arc is less than half a circle. You should know what a diameter is and a radius is and a circumference. Right. Circumference is distance around a circle. Okay, so here's some extra vocab and descriptions that you should know. Okay, please note these notations. All right, a semicircle uses 3 points to name it, and we have these little arcs above it to name an arc. All right, so STR. Okay, yeah, a minor arc we use 2 points. A major arc, which is more than half a circle, we use 3 points. Okay. So here, name 2 minor arcs of circle C. We have AB, we have PE, ED, and AD. Right? Look this part over carefully. And please look over this page as well. Right? You know, we know a circle is 360 degrees. Right? Therefore, a semicircle, half a circle is 180. Okay. Adjacent arcs are arcs that are next to each other in a sense that they share a common point. So, for instance, AB and BC are adjacent arcs because they share point B. Okay. And then finding the measures of the arcs. Okay. Please look this over as well. All right. You're given some information here. Okay. I'm actually going to backtrack here. One thing I forgot to mention, this where I'm highlighting is actually key, right? The measure of a minor arc is equal to the measure of its corresponding central angle. Meaning, if the central angle is 50 degrees, then the arc is also 50 degrees. Okay, they have the same measure. All right. So if you look here, that's why this red 77 degrees is here. The central angle is 77, PCR, so the arc measure, PR, or RP, is also 77 degrees, right? If this angle here, or if this arc here is 28 degrees, right, then angle SCQ, the central angle here, must be 28 degrees, all right? And so if you know that's 28 degrees, then that should help you get angle QCP, right? We know the circumference is the distance around a circle, right? And this should be a familiar formula. So the circumference is pi d or 2 pi r, okay, whichever one you want to use. Coplanar circles that have the same center are concentric circles, right? Circle within a circle. One thing I'm going to mention is we're going to leave pi as pi. We're not going to use 3.14 generally. Okay, so if you look at this example, right, you'll notice here we have 2 pi r. The outer radius, the larger circle, is 16.1, right? And so notice we leave our answers in terms of pi, meaning pi is going to be in your answer. So you should not be multiplying 32.2 and 3.14. We're just going to leave it like this. All right, kind of like a variable. All right. It says here the measure of an arc is in degrees, while arc length is a fraction of the circumference. Arc length, so an arc also has degrees, but it also has length. Okay, meaning like in inches or feet or centimeters or whatnot. Okay, it's part of the circumference. And so the arc length, I believe this formula will be given to you later on as well, right? The little m stands for measure, so the measure of arc AB divided by 360 times the circumference, right? That's what the measure of this arc AB would be. Okay, so here are a couple examples to go over. Please go over it. If you have questions on these examples, please let me know. Right?